When we left off last time, we had been discussing adaptations for altruism in humans and other species. And altruism is a behavior where an actor, the one who's being altruistic, is suffering an apparent cost to deliver a benefit to another individual. And this could include something like a man jumps into a river to try and save the life of someone else at a risk to themselves. This could be someone donates to charity. This could be somebody helps a friend move. And it doesn't even have to be in humans, of course. As we're going to see, this happens in other species too. The point is that the actor is suffering a bit of a cost to deliver a benefit to another individual. And these behaviors and the adaptations that generate them, these altruistic behaviors and the adaptations behind them, require special types of explanations. Because if you were to discover an adaptation that existed in one species, strictly for the benefit of another species, this would disprove evolutionary theory. And the same logic also extends to members of the same species. That is, if you find an altruistic adaptation in a species where one member is suffering a reproductive cost to deliver a benefit to another individual, if you can't explain that in terms of how the altruist is benefiting, you have also disproven evolutionary theory. So as such, when we think about altruism and adaptations for it, what we want to be looking for are the benefits that accrue to altruistic individuals as a result of their behavior. After all, if the altruistic actor is receiving important benefits from being altruistic that outweigh the costs they incur, then altruism can be selected for, and it's no different than any other adaptation. And we saw some concrete examples of this last time with respect to altruism between genetically related individuals. In one very simple instance, we have a case of multicellular life, like you or I. We have bodies that are made up of many, many different cells. And all the cells that make up our bodies are 100% genetically related to the other cells that make up our bodies. And since genes are the things that are actually getting reproduced in an evolutionary process, the genes are the things that evolution cares about. Organisms that are 100% genetically related to each other have entirely overlapping sets of reproductive interests. Because your reproduction, in this case, is the same thing as an identical twin reproducing. In both cases, you put as many of the genes in your body into another body into future generations. Similarly, if your identical twin were to die, this is evolutionarily, genetically speaking, like you dying. Your reproductive interests are entirely overlapping. And since evolution is really about the reproduction of genes, it's not terribly particular about which bodies those genes are located in. So as such, if you have a completely overlapping set of genetic reproductive best interests, you can easily get adaptations for altruism. This is why the roughly 30 trillion cells, human cells anyway, that make up your body are capable of specializing to be skin or muscle or liver or brain or heart cells. And they cooperate with each other very, very efficiently. And they even constrain their own personal reproduction for the good of each other. When cells stop constraining their own personal reproduction, that's called cancer. And it tends to be pretty fatal to the entire organism. And it's very heavily selected against in order to get this type of cooperation so you get good reproductive outcomes. So in the evolutionary sense of the word here, because these cells are 100% related to each other, they are each other, for lack of a better word. It's not even that they're not exactly each other, just have entirely overlapping reproductive interests as if they are each other. So you can think about it that way. In this case, the altruism, the benefit to helping other related cells is legitimately just like benefiting yourself. So long as you are helping them reproduce. As long as the cost of benefiting them is lower than the benefit that you derive, from your action, altruism can easily evolve. And so you have mechanisms that can result in organisms suffering a cost to themselves to deliver larger benefits to relatives, and that can easily be selected for. That's simple altruism. And this process that we saw of adaptations arising because they benefit copies of your genes found in other bodies, we call this kin selection. And we also saw another great example of kin selection last time, which are mammary glands, the tissue that produces milk in females and mammals. They're a great example of physiological adaptations for altruism, where the biological costs of developing this tissue, producing the milk, and delivering that milk to the offspring, all the costs of this are shouldered by the mother, and all the metabolic benefits are gained by the offspring. And again, it appears that these adaptations result from a process of kin selection, where even though the mother and the offspring in mammals are only 50% genetically related to each other, there's still some degree of genetic overlap and thus shared reproductive best interests between parents and offspring, and that can result in adaptations for altruistic organs, like mammary glands, like umbilical cords, and also altruistic behaviors, like I'm going to find food for my offspring, I'm going to feed them, I'm going to clothe them, I'm going to house them, I'm going to protect them. And we also saw last time that mothers are more likely to develop these adaptations for altruism, these physiological and psychological adaptations for altruism, to a greater degree or more readily than fathers do. And we saw this is again a result of genetic relatedness. Because even though mothers and fathers are 50% related to their offspring, at least in mammals, mothers are the only party that are assured of their genetic relatedness. That is, as we said, they're mama's babies and their father's maybes. And so because the mother can be guaranteed of her genetic relatedness to the offspring, this cost-benefit ratio starts looking a bit different for her. The father always has this degree of uncertainty in the relationship. The children might be his, the children might not be his. And if the children aren't his, the cost of behaving altruistically skyrocket and the benefits plummet. So mothers tend to become more altruistic because they can be assured they're investing in their own kin in a way that fathers simply can't. And the implications here extend to the psychological adaptations as well as the physiological ones. It's not just your own offspring, it's not just your own body, it's also your behavior towards other relatives. And the more closely related organisms are to each other, genetically, the greater the possibility that these adaptations for altruism will exist, will develop, will be utilized. And as relations get more distant and less certain, your child is more closely related to you than a first cousin, and mothers are more certain the children are their own children relative to their fathers. So as these relations get more distant and less certain, people become less interested in helping their kin, choosing to preferentially invest in closer or known relationships when possible. And as we also saw, much of this altruism flows from older individuals to younger ones. And that's simply because of this cost-benefit ratio again. Not only are younger individuals often less able to help older ones, but even when they are able to, younger individuals simply have a larger reproductive future in front of them. And so putting resources into that vehicle for your genes is likely to yield a greater benefit. A child who is 18 and a parent who is 78, the parent's going to invest in that child more because the child, all else being equal, has at least 60 more years of reproductive future, assuming they grow to be as old as their parent, while their parent certainly does not have that long. So we see that altruism flows typically from older individuals to younger individuals because of that cost-benefit ratio. And finally, one example we discussed last lecture of what doesn't count as altruism is when incidental benefits are produced by one organism for another. So in this case, there are waste products that animals produce, dung, for instance, and this could serve as an important nutrient for another animal, like the dung beetle you see here, or flies, or other insects. The benefit is derived by another species. So when an animal's producing dung that is eaten by an insect, the insect is benefiting, but those benefits are a byproduct of adaptations for waste removal in the animal. Nothing about the waste removal adaptations in the animal appear to be well explained by trying to deliver benefits to the insects or whatever other species. So you don't want to look for cases where the benefits are byproducts. You want to look for cases where the benefits are intentionally, adaptively delivered. And this is going to serve as a nice jumping off point for today, where we're going to consider how altruism can exist between non-relatives. We're going to step outside of kin selection and look for why people and other species behave altruistically towards each other. And as we know from our personal lives, as well as the vast literature on many other animal species and humans, cooperation and altruism can sometimes exist between non-relatives of the same species or even between members of different species. When you help a friend move, or you go to your job, or you go to a restaurant and someone gives you food, any acts like this, you have experienced a case of altruism. In this instance, one actor is suffering an immediate cost in terms of time or resources or energy or risk to their own life, whatever, to provide a benefit to someone else. Our psychological adaptations that create and govern such behavior need explanation in this case, and that's exactly what we're going to move on to today. So what we're trying to do with our explanations for altruism is, in essence, we're trying to take the altruism out of altruism on the ultimate level of explanation. That is, we're trying to make altruistic less focused on I suffer a cost to deliver a benefit to you, and more focused on what benefits I receive because of my altruistic behavior. We want to be looking for benefits to the actor to explain altruism. We don't want to be looking so much at the costs, because the costs are probably not going to explain the behavior. What we want to find are what benefits accrue preferentially to altruistic individuals as a result of their proximately altruistic behavior. Provided the benefits that the organisms are receiving from behaving altruistically are larger than the costs of generating that behavior, at least on average, adaptations for altruism can arise and be selected for. So in search for benefits that explain altruism between non-relatives, let's start in the most extreme case, where we're going to look at altruism that occurs between members of different species. Because here, it's pretty obvious that any shared genetic relationship is going to unlikely to be the explanation for anything. They are different species. They share relatively fewer genes in common. They can't mate with each other. They can't have each other's children. And yet they can still cooperate. And you can see an example of that right here, actually. That is, one broad case of this altruism that exists between other species involves marine life, specifically fish here, that can arise between different species. In this case, you have a host, you have this big fish here, and you have the cleaner species, which are the smaller fish. These hosts are often infected by parasites, and they will actively seek out cleaner species that preferentially feed on these parasites. In fact, some of the cleaner species are so specialized in doing this that parasites eaten from a host are pretty much their only source of food. That's how deeply ingrained these relationships can become. Now, these parasites sometimes reside on the skin of the fish, the exterior, but also sometimes you find these parasites in the gills of the fish. You find it inside the mouths of the host fish. And when that happens, as we see here, the host fish will open up its mouth, it'll open up its gills wide, and it'll maintain a certain pose. It'll stay still and allow the cleaner fish to swim inside of its mouth and inside of its gills to clean out the parasites. And in fact, these species have also co-evolved signals with each other. So cleaners will swim in particular patterns and have particular colorations to signal their interest in cleaning a host, while the host sometimes is going to swim in particular ways to signal that it's about to leave so the cleaner fish can exit its body, get out of its mouth, whatever, safely. There's a very tight co-evolutionary relationship between these two species. And you can tell this is incredibly common because if you look at the stomach contents of the host fish, they will rarely, if ever, eat the cleaner fish. Even though the cleaner fish are inside of their mouth, the host fish easily could swallow them, rarely does. Even once the cleaning is complete, the host doesn't eat them. It signals it's going to leave and lets the cleaner fish leave it. And if you want to know exactly how deeply ingrained these evolutionary, well, I guess co-evolutionary races have been, there are examples where you take a fish and you raise it alone in a tank for 6 years. And this fish is very used to eating anything you drop into the tank. If you take a cleaner species for that fish and you drop it into the tank, not only will the host fish not eat it, but it will immediately start signaling in certain ways that it wants to be cleaned, and the cleaner fish will clean it and it will let it go. And everything you see in the wild happens in fish that have been raised in captivity and isolation for years. It's very deeply ingrained in the psychology of these fish. And so in these interactions, in both the host and the cleaner, we are seeing some altruistic behaviors. The host, it takes time out of its day. It takes risk to its life to go travel and seek out and find the cleaners. It adopts certain abnormal poses and behaviors for extended periods of time to allow the cleaners access to its body. And then it will signal its departure rather than eat the cleaners, foregoing what could be a free meal. The host fish is enduring a series of costs or failing to reap a bunch of benefits and delivering these benefits to the cleaner fish. Or by contrast, the cleaner fish are entailing some risks in being eaten by the host fish and other predators during this cleaning, and they're also avoiding taking any bites from the host. So, now we just have this interaction with the host and the cleaner. Both of these endure some costs for the interaction, and both of them exit the interaction with benefits. So the host gets the parasites removed, the cleaner fish leaves with a meal. Now, altruistic acts like these that occur between non-relatives can often be explained by what's called the theory of reciprocal altruism. In its most basic form here, the idea is that altruism can prove to be adaptive, provided the altruism that you provide at one point is later returned to you at a future time point. And you can think of this in terms of the common phrase, I'll scratch your back if you scratch mine. Because you can't reach your own back very well to scratch it, other individuals are really well positioned to provide you a unique benefit at a cost to themselves. The time, energy, risk, whatever it takes for them to scratch your back. And so long as you return that favor in the future and provide them with some benefit at a later time, you can both become valuable to each other and gain access to benefits that you would otherwise miss out on. And as we saw in the case of the cleaner fish and the host interactions, these benefits merely need to accrue between cooperators no matter their relationship to each other. They could be not family members, they could be strangers, they could be members of a different species. But there are a few key conditions that have to be met before reciprocal altruism can evolve. Much like last time we saw Hamilton's rule for kin selection, where the cost of the act has to be less than the benefit to the recipient discounted by the degree of relatedness. We saw that was the condition for kin selection adaptations for altruism to evolve. There are similar evolvability constraints that have to be met for reciprocal altruism, otherwise it just isn't going to occur. And to get a better sense for those conditions, I want to consider what is known as the prisoner's dilemma, which you can see an example of here, because it illustrates the challenges to reciprocal altruism evolving very well. So in this hypothetical situation, in this prisoner's dilemma, the story is that there are two criminals that have been working together to rob a bank. and they've been caught by the police, and they're being interrogated in separate rooms. The police currently don't have enough evidence to convict either prisoner of a major charge they're suspected of. They can't convict either of them of bank robbery based on the available evidence. But the police do have enough evidence to convict both of them of a smaller charge, like, let's say, conspiracy to rob a bank. The police can get them on this smaller charge. They don't have evidence for the bigger charge. And these two prisoners are being interrogated in separate rooms where they can't communicate with each other. In this case, bank robbery carries a 10-year prison sentence, while conspiracy only carries a 1-year prison sentence. So in this case, the police are able to convict both of the prisoners to 1 year in prison based on available evidence, but not 10. And the police want to convict them for 10. So what they do is they offer each prisoner a deal. And they say, if you cooperate with us, if you confess to the act and implicate your partner, if you defect on your partner, if you cooperate with us, the police, you're going to get a reduced sentence. In fact, if you confess and tell us what we want to hear about this other person, you can walk free. You're going to get out of here with 0 years in jail. And your co-conspirator is going to get convicted on the full charge. They're going to get 10. However, if both of these prisoners confess on each other, they both end up getting 5 years. So would be 10 years for the bank robbery sentence. Both get a reduced sentence for cooperating, but it's still 5 years. And this creates a very interesting payoff structure here. If neither prisoner confesses, both end up getting 1 year in jail. If both of them confess, they get 5 years in jail. So, on that basis, it seems better for them to not confess. However, the way this is set up, if either one of them confesses, you're better off still. Because if you confess, well, then you get no years in jail. And both prisoners understand this. And this creates a context where it's always better to confess. Always better. Because if your partner doesn't confess, and you do, you get 0 years. Your partner gets 10. If you confess, and your partner confesses also, now you're getting 5 years in jail instead of 10, which is better for you as well. So if you cooperate, you are putting yourself at a disadvantage relative to if you defect. And that's what makes this the dilemma. Both of you are incentivized to confess. But if you both confess, you get 5 years in jail, which means both of you would have been better off at that point not confessing. So how you manage this dilemma, how you solve this dilemma, is in many instances the key to the issue of reciprocal altruism in general. It really highlights the issues of reciprocal altruism, the challenges of evolving it well. There are benefits that organisms can provide for each other, like the cleaner fish removing parasites from a host, and then the cleaner fish get a meal, the host lose the parasites. Or you go to a restaurant, to use a more mundane example, and the restaurant gives you food, and then later you are expected to give the restaurant money, so you get a meal in exchange for the money that you pay. Reciprocally altruistic behaviors. But this exchange of behavior is occurring with a time lag. That is, it's always immediately costly to provide this altruism to another person, whether in terms of time, energy, risk, or whatever. And it's always uncertain whether this other person is going to repay you. So, for instance, if you go out to eat at a restaurant, it is costly for the restaurant to provide you the meal. They need to have people working there. They need to be paying their rent. They have to cook the food for you, deliver it for you. And they are hoping that you're going to pay the tab at the end of the meal, and that you're not just going to eat the meal and then walk out the door. What you would call a dine and dash. The cleaner fish could, another example, remove parasites from the host. They swim into the host's mouth, start picking out parasites, and when the host feels it's been cleaned, it just eats the cleaner fish. So now the host got cleaned, and it got a free meal. This mimics the prisoner's dilemma very well. Both sides are incentivized to cheat. I'm incentivized to get a meal at a restaurant and leave without paying. The host is incentivized to get its parasite cleaned and then eat the cleaner. Just like the restaurant might be incentivized to take your money and then not give you food, or the cleaner might be incentivized in some capacity to get a benefit from the host without cleaning its parasites. And we actually have a really good example of that latter thing, of a cleaner fish that is a cheater in the relationship. A cheater is what you would refer to as an organism that takes a benefit without paying the reciprocal costs later. In the literature on altruism, that's what we call the people that are defectors, cheaters, ones who do not repay their debts. And under some circumstances, cheating becomes the evolutionarily favored strategy after reciprocal altruism has evolved. There are examples of fish, for instance, that are different species than the cleaners, but they evolved to look an awful lot like the cleaners. They're the same general size, they're the same general color, and they even show the same general behavior of the cleaner species. They swim in distinctive ways, they behave and they act as if they're cleaners. And what the host fish does is it, opens its gills or opens its mouth or whatever, lets the cleaner fish mimic go about its business, and then the mimic takes a bite from the fish's body and swims away before the fish can eat it or defend itself. That we have this reciprocal altruistic relationship that has evolved, and then an entirely different species has evolved to take advantage of that existing interaction by cheating it. And the costs that these cheaters inflict have to be constantly fought against for reciprocal altruism to be maintained. Because as we see in the prisoner's dilemma, there is a constant incentive to defect from altruistic relationships, to cheat, to take the benefits and run and not pay the costs and leave your cooperative partner at a loss. There's always an incentive to cheat. So there has to be a constant incentive to maintain the relationship. And all of what we're talking about so far, right now we're just thinking about relatively immediate interactions. I go out to eat, and very shortly after I'm expected to pay my bill. The cleaner fish is cleaning me, and very shortly after I'm expected to not eat it. But in humans, sometimes reciprocal altruism goes even further. It can be you help me today, and I'll pay you back tomorrow, or in a week, or in a month, or in years. So we need to start really thinking about what conditions need to exist to favor these type of altruistic interactions. So first, there has to be a proper cost-benefit structure in place. That is, if one organism can't provide a benefit to another at a lower cost, then reciprocal altruism makes no sense. To put this in a very simple money example, if I could pay $5 of my own money to give you 10, and you have the opportunity to do likewise, then we can have a mutually beneficial relationship, because then you're getting more and I'm getting more. However, if I can only spend $5 to give you $5 or less, and there's no possible gain from this cooperation, you can't get reciprocal altruism, because all we're doing is either incurring a loss or risking incurring a loss, and that's it. There's no benefit to be found. So in order for reciprocal altruism to evolve, there has to be a proper cost-benefit relationship where I can provide you benefits at a greater level than the cost takes me to provide them, and you have to be able to do likewise. So this tells us where we should start looking for reciprocal altruism, where there is a possible and expected exchange of benefits. And it also tells us when we see altruism that's one-sided, like one person donating to a charity with no expectation of direct repayment, we're going to need a different type of explanation for that behavior. In order to explain reciprocal altruism, the benefits have to be back and forth. They have to be reciprocated. Another feature of the world that's going to encourage reciprocal altruism is the repetition of interactions. That is, in a prisoner's dilemma that we saw before, If you only play the game once, it's always in your best interest to defect. It's always in your best interest to be a cheater if you're going to play the game once, because there's no other strategy you can take that ends up getting you a higher expected payoff. No matter what your opponent does, it's better for you if you cheat. But if you play something like the Prisoner's Dilemma with the same partner over and over again, repeatedly, what you call an iterated Prisoner's Dilemma, it becomes possible to gain benefits through cooperation. When the game is repeated, mutually cooperative partners, mutually cooperative alliances, can easily outcompete the cheaters. Indeed, this was empirically demonstrated some time ago, where there was a computer tournament hosted for the Prisoner's Dilemma. A challenge was put out for competitors, computer scientists, economists, scientists, smart people. They said, this is the Prisoner's Dilemma. Your job is to create a strategy that reaps the greatest amount of rewards in 200 games. You're going to play 200 rounds of the Prisoner's Dilemma against these other strategies. Your job is to get the best payoff overall. These strategies were capable of remembering each other, such that strategy A knew that it was playing in strategy B or C, and what that individual had done in the past. And we had 14 different strategies that were submitted to this tournament. And the winner of the tournament was a simple program. It was called Tit for Tat. And it did two things. It always cooperated on the first round with a partner, and then it did whatever the opponent did last round. So it cooperates with that opponent. If that opponent often cooperates, the next time it runs into it, it will cooperate again. It cooperates in the first round with the opponent. If that opponent defects, it will defect the next time it sees that opponent. And that's all it does. It just cooperates on the first move, and then it mimics whatever the opponent did the last time that it saw it. And in this very simple strategy, Tit for Tat was able to outcompete every other strategy in the tournament. Because what it did is it reaped the benefits from cooperative partners, and it failed to suffer long-term costs from cheaters. In fact, this strategy was so elegant in its simplicity, on a metaphorical level, it was actually kind of capable of forgiving cheaters that reformed. That is, if you cheated me 5 times and then you cooperate with me, it would forgive that cheater and reestablish cooperation. It didn't hesitate to do so either. It was just looking for the benefits of cooperation wherever it could find it, and avoid the costs of cooperation whenever it was appropriate. And this tells us some very interesting things also about where to look for reciprocal altruism and any associated adaptations for it, psychological features for it. Things like feelings of trust or belief in the goodness of others. These type of psychological features that run along with reciprocal altruism. And that is, you should be looking for it preferentially in environments where interactions are repeated between known individuals. In other words, you're looking for altruism in worlds where there are reputations. Because if all interactions are occurring between individuals only a few times, or even just once, it's very hard to establish reciprocal altruism. Similarly, if the interactions frequently occur between strangers, between people who you don't know how they're going to behave or have behaved in the fore, it also becomes harder to establish cooperative relationships relative to situations where you have the same individuals interacting repeatedly. So we want to start looking for reciprocal altruism where individuals, cooperators and cheaters, whatever, will live around each other for long periods of time, and not when those interactions are infrequent or between a constantly shifting number of different organisms. We want frequent interactions with the same actors rather than infrequent interactions with strangers. So this also means if you want reciprocation to take place, you do need some physiological and cognitive mechanisms to accurately track and remember individuals and their past behavior before you can establish any type of relationship with them. And further, we also might go on to expect that if you think these interactions are about to cease, That is, if I know this is the last round of the prisoner's dilemma I'm going to play with you, the incentive to cheat or defect should go up, because I know I'm not going to interact with you anymore, and so there's no more point to cooperating. So this means you might also expect to find reciprocal altruism in longer-lived species relative to shorter-lived ones, because a high probability of death entails a low probability of repaying favors. And also you have to look for the right cost-benefit ratio, as we mentioned before. Because this tit-for-tat program, if it met a defector, it would initially suffer a loss. If suffering a loss from cooperating is a very damaging, very large loss, it's unlikely you're going to establish reciprocal altruism. Similarly, if the benefit to cooperating is relatively low, it's unlikely you're going to establish altruism relative to a time when the costs to getting cheated are lower or the benefits to cooperating are higher. The nature of the cost-benefit ratio here is going to be vital. So I'm going to take these factors and I want to put them into two quick real-life examples, and I want to see how they might help inform our understanding of things. In the first of these, I want you to imagine that you know you're going to die soon. You knew for a fact in exactly 1 year from right now, you're going to die, and you have no dependent children or family to whom you might pass on your wealth. If you knew for a fact you were going to die in a year, this would probably encourage people to do a couple interesting things. They might, for instance, quit their job, breaking established cooperative relationships. They would probably empty their savings account because you can't spend your money after you die. They might take out large loans from credit institutions that they have no intentions of paying back because you're not going to suffer the costs of the repayment and the interest. And you'd probably spend a lot of time engaged in all sorts of behaviors that are more gratifying in the short term. Classic lifestyle of sex, drugs, and rock and roll. After all, if there is no future for you, then there aren't costs to cheating, because you're not going to be able to reap the eventual benefits of cooperation anymore. So you're best off just defecting. And we can make this a little less hypothetical. There's an interesting story I've come across several times. It's been recounted online. This isn't exactly a scientific study. This is just something I have read, but I think it's interesting all the same, because it paints a fun picture. Specifically here, they ask nurses in hospice care. These are nurses who are working with elderly individuals at the end of their life. And they're interacting with a lot of these older individuals at the end of their life. And they're asking the nurses, what are the patient's greatest regrets? What do the patients say they regret the most in their life? And there are 5 answers that were highlighted as the most common. I wish I had the courage to live life true to myself and not the life others expected of me. I wish I didn't work so hard. I wish I had the courage to express my feelings. I wish I had stayed in touch with my friends. I wish I had let myself be happier. And of those 5, 4 of them sound an awful lot like someone who's focused on short-term benefits at the expense of long-term ones. And naturally so, because for these people, there isn't a long-term future to look forward to anymore. I wish I had the courage to live life truer to myself and not the expectations of others. What does this translate to in language of reciprocal altruism? I wish that I had done what I wanted more and what was good for me more instead of what benefited other people. Because now the cooperative relationships are coming to an end and I can't get those benefits anymore. I wish I had reaped more benefits. I wish I didn't work so hard. I wish I invested less time in cooperative relationships with others. I wish I delivered fewer benefits to other people and took more time to deliver benefits to myself. I wish I had the courage to express my feelings. I wish, instead of being polite and staying cooperative and reciprocally altruistic, I had told people what I really wanted to think about them and what I really wanted to do, even if this could threaten the cooperative relationship, because again, no more future in it for me. And I wish I had let myself be happier, same thing. Wish I was looking for benefits for me rather than benefits delivered to other people. 4 of those 5 sound extremely interested in more cheater-defector type language than in long-term cooperative language. And even the 5th one, I wish I had stayed in touch with my friends more. Even that might reflect the fact that at this moment, the people who were dying are probably lonely. And maybe in that moment, they wish they had more people around them to deal with this short-term grief or sadness that they're feeling. I can't say for certain, but it's at least consistent with the idea. When there's no more shadow of the future, people sound a lot less cooperative, a lot less interested in suffering any personal costs to deliver benefits to other people. Another interesting example we might consider is the nature of our online lives, the interactions that we have through the internet. And as many of you are familiar with, these interactions online can become nasty in an extremely short amount of time. Almost instantly in some cases, as anyone who has visited the comments section of about any news article or any YouTube video or any online forum can attest to. Interactions online get nasty, and they get nasty fast. Understanding why this happens can to some extent be made easier by thinking about the conditions required for reciprocal altruism to exist. That is, the people you interact with online, at least initially, a lot of them, are usually strangers instead of individuals that have a known reputation to you. Interactions with the same individuals are often infrequent rather than repeated. The person on the comment section that you see today, you're probably not going to bump into him again. The ability to deliver meaningful benefits to each other can sometimes be limited in these online interactions. And there are many possible people you might interact with online, reducing any degree of interdependence between cooperators. And in many cases, these interactions can even be pseudo-anonymous, preventing any type of reputations from forming in the first place, much less being useful for informing any future behavior. So that is, if you're interacting online with a particularly disagreeable person, a liar, a scammer, a troll, if they cheat you, if they harm you in some way, if they're not cooperative towards you, this really doesn't in any way deter them from going out and having interactions with other people in the future. They don't depend on you. They might not bump into you again. All the stage is set for them to take advantage of you, to be mean, to not cooperate, to not be altruistic. So knowing what we do about the context that can create cooperation, it should really come as no surprise that a lot of these online interactions tend to be frequently different in important ways from in-person interactions. While these conditions might not be the only reason online and in-person conversations differ, like you're not going to get punched in the face online, these factors are still important to think about. And that's why I wanted to draw your attention to this little diagram here. This is from the Pew Research Center. It's an article that came out in 2014. It was looking at political polarization in America, though this happens elsewhere too, I imagine. And they found that over time, there have been massive shifts in the degree of political polarization. This was back in 2014. So we're almost a decade out from this, and as far as I've been able to tell, the degree of polarization has not felt like it's meaningfully decreased. If anything, it feels like it's gotten worse. And I can't help but wonder to the degree that this arises because of the rise of the internet. That is, when people no longer require established, in-person, reciprocally altruistic relationships as regularly, because you can just go online and you can find new potential cooperative partners, you can get goods and services from strangers at the click of a mouse. You don't need those in-person interactions anymore. The degree to which you need to compromise has really been reduced. Why would you need to compromise your views to cooperate with someone else to reap benefits if you can just go online and get those benefits kind of anywhere from anyone, and find the people who think the way you do, and find the people who like the things you like? And if you're a jerk to other people, well, so much the worse for them, but you're never going to interact with them anymore anyway. Why are you going to bother being nice to someone only 40% aligned to your views and suffer those costs of cooperation when you can get the same benefits from someone who's 70% aligned with your views or 80% of aligned with your views? So while I wouldn't say I have great support for this idea, at the current moment anyway, it's something I would strongly suggest thinking about more in the future, that it's possible that while the internet can provide a lot of great things and a lot of great interactions and a lot of very useful services, when you have this ability to decouple a lot of your life from these intimately, reciprocally altruistic interactions that you have repeatedly with known individuals, you can sometimes end up getting a more nasty series of interactions, less convergence, less compromise on viewpoints. Just something to think about when it comes to your own online life. So now that we've covered the idea of reciprocal altruism and seen some examples of it, I want to move on to some studies looking for evidence of psychological adaptations for solving these key adaptive problems of cooperation and specifically cheater detection. So we're going to begin with a basic logical game here. Logic in this case just follows a simple if-then statement. If P, then Q. P and Q are variables. Fill in those however you want with whatever you want. And as many people would suggest, that humans are a logical and reasonable species, and because the ability to reason logically about the world is so useful, we might expect people are pretty good at general, abstract, logical reasoning problems. So we're going to do one right now that's about as basic as we can get. Right here we see 4 cards. Each has a letter on one side and a number on the other. You can flip over as many of these cards as you want to verify the following rule. Any card that has an A on one side has a 7 on the other. And your job is to flip over as few of cards as possible to verify whether this rule is true. So if a card has an A on one side, it has a 7 on the other. Which cards do you want to flip over? If you're like the vast majority of people who have ever seen this test, you probably answered A and 7. And you would also be wrong, or at least half wrong anyway. It is correct to flip over the card that says A. Because if the card that says A doesn't have a 7 on the other side of it, the rule has been disproven. However, if you flip over the card that says 7, that's kind of pointless. Because the rule doesn't say every card that has a 7 on it must have an A, just that all cards that have A must have 7. A card with a B on one side and a 7 on the other is perfectly consistent with this rule. Instead, the card you want to flip over here is the 4. Because if there's an A on the other side of the 4, then the rule will be proven wrong. And abstract problems of this nature, if P then Q type of reasoning problems, these have been posed to people time and time and time again, and people keep getting them wrong regularly. Most people, 80-90% of people who see this problem, get it wrong. And why does this happen? Is it because humans are actually not logical creatures capable of reasoning? Well, sort of. The answer here is likely that people haven't actually evolved any cognitive adaptations for solving content-free logical problems per se. Instead, like in other domains, we've more likely evolved cognitive mechanisms that are functioning to reason about specific domains and specific problems rather than in this more general sense. Like as we saw before, rats are specifically able to learn locations of food and water differently, rather than having some general mechanism for finding things they ingest. And that is, in humans here, we seem to have some adaptations for monitoring social contracts. This idea that if I receive a benefit, I must meet a precondition, I must pay a cost. Our brains are ready for looking for social cheaters, people that take benefits without meeting the requirements, people that take benefits they're not entitled to or aren't going to repay them. And we can see how people change their reasoning abilities based on this domain. You take the exact same card selection task, but all you do is vary the content to match social exchanges. The kind that resemble those reminiscent of the ones people would typically encounter throughout our evolutionary history. So if I showed you these cards and said, you have to verify a following rule. To drink alcohol, you must be 21 years old. Think about which cards you're going to turn over. Well, here the answer is pretty easy for most people. They check the person who's drinking beer, and they check the person who's 17. 17 is not old enough to drink, and if they're drinking, the rule is proven wrong. The person who's drinking beer needs to be of legal age. If you flip that over, then the rule is proven wrong. Where someone's drinking soda, there's no rule about how old you have to be to drink soda, and if someone's 25 years old, it doesn't matter if they're drinking beer or soda. So in this context, people become incredibly skilled at solving this task. They accurately select the right cards. Even though the underlying logic of this problem is identical, if P then Q, people show vastly different performance when the problem is framed in different contexts, in this case of a social contract. If you have an abstract case, they perform very poorly. If you have a social contract, they perform very well. And I'm sure some people are looking at this and thinking, well, that's just because people are more familiar with rules about drinking alcohol and being underage, but that actually can't really account for performance here. That is, if we take this exact same task and we reframe it in terms of social rules people are unfamiliar with, like if you want to get married, you must have a tattoo on your face, we still find that people are incredibly successful at solving these logical problems. There's about 75% of people will get the answer right when you frame it in terms of a social contract, familiar or unfamiliar, whereas only about 10 to 20% of people will get it right with more of the abstract reasoning, even though the underlying structures of the problems are identical. So performance on this task is relatively consistent, whether you frame it as a familiar or unfamiliar social exchange. The important part is that you're using a context of social exchange. Conversely, if you show people cards related to familiar activities, but they're not social exchange, their performance is not as good. So that is, if I gave people a rule that says, if you're going to Boston, you are traveling by subway, or if a person eats hot peppers, they will drink a cold beer, performance is not as good. About 40% of people will get it right in those contexts, but it doesn't compare to the 75+% of people that get it right in this one. Social exchanges appear to trigger people's reasoning abilities to behave correctly in this case because we're reasoning about something that was historically relevant as opposed to some abstract nonsense. And these findings have been replicated cross-culturally, which is strongly suggesting that there are adaptations in the human mind that focus on solving problems of detecting social cheaters. And that makes perfect sense for a species like ours that regularly engages in reciprocally altruistic relationships. Anyone not looking out for cheaters regularly would get taken advantage of, and they would suffer costs, and they would not be as successful as those that were looking for opportunities to avoid getting exploited, just like the tit-for-tat program did. So the matter of whether humans are skilled reasoners, then, on these logical tasks, it really critically depends on what thing they're reasoning about. When it comes to abstract problems, humans are often not very good at reasoning. We perform pretty poorly. But if you're thinking about social exchanges, we suddenly become skilled reasoners. And these findings are very difficult to account for without thinking about some type of functionally specific cognitive mechanism that evolved for solving this task. Because clearly, if it was a general program just for reasoning about if P then Q relationships, it should perform well across domains. We don't. We perform contextually well depending on the domain we're reasoning about. And indeed, one thing people might be reasoning about in particular ways in these social exchanges is whether you are personally getting cheated or not. So what they do is they take this card selection task and they reframe it in terms of personally relevant factors. Specifically, the 4 cards they show to people are related to work. They say, has a pension, a retirement basically. They have a pension. They have worked 8 years. have no pension, have worked 10 years. And they ask participants to test the rule that if an employee gets a pension, they must have worked for 10 years. Again, exact same underlying logical problem. The twist here is that they tell people either you're the employee or you're the boss. So what happened, this really matters here because this counts towards what's a benefit and what's a cost. If you're the employer, if you're the boss, the pension is a cost to you. You're spending your time and your money investing in someone else. For you, the pension is a cost. But the employee working is a benefit. That's the employee being cooperative and nice towards you. This flips when you're the employee. When you're the employee, the pension is the benefit. It's the thing that you want to get. But the work, the time and energy that you're investing in your job is the cost. So what happens when you have two groups of participants that are doing this task, but you tell one they're the employee and one the employer? Well, the answer is they start looking for cases where they might have personally been cheated. So the employers, the bosses, flip over the card that says, has a pension. This person is taking a benefit from me. They are inflicting a cost. And has worked 8 years. Hasn't fulfilled the precondition. So employers are looking for people who are costing them by not providing enough benefits or taking something from them. Employees, by contrast, not actually employees, but people have been told take the perspective of an employee, flip over the cards no pension and has worked 10 years. Because for the employee, the pension is a benefit. They want to see, am I missing out on my benefit? And if I have fulfilled my cost, am I getting the benefit? So again, employer looks for has pension. Employee looks for no pension. Employer looks for worked 8 years. Employee looks at worked 10. So people are getting the wrong answer or the right answer to the question to test the rule if an employee has a pension they've worked for 10 years, depending on what perspective they're taking. So are people skilled reasoners? Well, it depends on the context, depends on the content, depends on your personal perspective. And we can push this example even further, because humans are unlikely to have adaptations for looking for pure altruists. A pure altruist would be someone who cooperates with you no matter what you do to them. If you cooperate with you, they're going to cooperate back. And if you defect on them, they're going to cooperate with you anyway. It doesn't matter how many times they do this. A pure altruist will always cooperate. We probably have no adaptations for locating pure altruists. And the reason is very simple. Pure altruists don't exist. And there would be no point in trying to have an adaptation that locates a non-existent thing. By contrast, cheaters do exist. There's always an incentive to cheat, and we seem to have pretty good adaptations for finding these cheaters. So while it might be valuable to you to find a pure altruist because you could take advantage of them constantly and benefit yourself massively, we probably don't have adaptations for looking for them because pure altruists just never existed. So to test this, they again run people through the exact same social exchange card selection task, but they ask them to look for selfless individuals. That is, individuals who paid costs but did not take benefits. And performance on this task was relatively poor compared to when they were looking for cheaters. People are pretty good at looking for cheaters, but they're not particularly as good at looking for altruists. And that's because cheaters pose a larger problem to you, whereas pure altruists probably never really existed. And again, looking at more examples of this card selection task, something also very similar happens when you ask people to look either for cheaters, as is usual in this example, or just look for people who have violated the rules if that person's not going to personally benefit from them. That is, someone who violated the rule but just by mistake. They're not a cheater, they just made a mistake. As it turns out, taking benefits is really a key feature that cues this cognitive system to look for cheaters. That is, they had two such experiments here, where the card selection task is either framed as cheating, someone took a benefit but didn't pay a cost, and as usual in this case, about 75% of people get it right, or, in the other case, people violated a rule but they didn't personally benefit. They just made a mistake. In this case, people only get it right about 20 to 30% of the time. And that jump, 70% to 20%, is fairly massive. And the only thing that really differs in this case is whether the person who violated the rule personally benefited. If someone's not benefiting, it seems that the adaptations for detecting cheaters aren't turning on. They're not getting the proper stimulus, and so they're not activating and they're not performing. And all these examples, again, really work to focus on this point that the human mind is not some general purpose mechanism. We don't use these context-independent, logical, or reasoning mechanisms to solve all problems equally well, whether they're abstract or whether they're concrete. Instead, it appears the architecture of our mind is specifically tailored to the details of solving important adaptive problems of detecting cheaters, which includes looking for those who took benefits without paying costs. The moment you have that set up, humans suddenly become very skilled reasoners, whereas in more abstract cases, our ability to reason can plummet. And even if you put them in cases where you are talking about social exchanges, people start looking out specifically for instances where they might have been cheated, even if that means reasoning incorrectly. People want to find cheaters, but we're not particularly skilled content-independent reasoners. So far here we've been talking about a lot of social exchanges that have entailed the expectation of reciprocity. I will help you with the expectation that you will help me in the future. While understanding this idea of reciprocal altruism is vital for explaining an incredibly large number of human behaviors, and non-human behaviors for that matter, it really doesn't quite cover all facets of altruism. For instance, some people donate money to charity knowing full well they are never going to get that money paid back to them, or that the charity is going to provide them with some other non-monetary benefit. Why would someone ever provide help to a charity like this? Provide help to a non-relative that they are not expecting repayment for. Explanations for this type of altruistic behavior, which, by the way, happen to explain a great deal more, is what we're going to get into next time. And as a small preview of where we're going to be going here, it turns out that actions really do speak a lot louder than words. And the things that these actions are capable of communicating to others is vitally important to a lot of life, a lot of species, even if they are more or less invisible to the naked eye.